doesn't mean that my magnitude is actually negative. That just means my final direction is going to point west, and it's just going to be the absolute value of that number. So if my final answer comes out to negative 30 miles, then that doesn't mean that my magnitude is actually negative 30. I'm just going to draw my arrow going west, and I'm going to write 30 miles, okay? If my answer comes out positive, that means I'm going to draw my arrow going east, and I'm just going to write whatever the answer was, okay? So these are your two planes. Everything north and south, you're going to combine it, add, subtract, whatever. Everything west and east, you're going to combine it, so that in the end, you should come up with one vector going either north or south, and one vector going either east or west, okay? So that's step one, reduce it down to two vectors, okay? Now, once you have your two vectors, you're going to combine them tail to tail, okay? What that means, we've talked about it before and it seems to have caused confusion, but three different ways of saying it. You can say tail to tail, you can say butt end to butt end, however you want to describe it. But overall, what I want you all to get is that the arrows should not touch anything. The arrows, the end tips of your arrows should not be touching anything. So if I've got one arrow going this way, my other arrow is going this way, all right? That means I'm going to draw one arrow, start it off that way. My next arrow, the tip should start right here or the tail should start at this tail. So I'm going to go to the tail, and I'm going to draw the rest of that arrow down. Okay, very straightforward. The tails should be touching. Okay, if you were to draw it like this, that would be incorrect. Okay, because the tails are not touching. The head of this one is touching the tail of that one. So that's no good. Now let's try another example. If my arrow's going that way and the other one's going this way. Okay, if I draw it like this, is that correct? It's not correct, okay? Because the head of that arrow is touching the tail of that one. No good. It doesn't matter which one you start with. In this case, let's start with that one, okay? So I just redrew that one to start with. When I draw this other one, I start the tail of it where the tail of this one is, and I'm going to draw the rest of it that way. So my tails are touching. That's good, okay? So that's step two. Just take your two resultant vectors, make the tail of one touch the tail of the other, okay? Step three is to draw your diagonal, okay? So when you draw your diagonal, you've already got your vectors drawn. I like drawing dotted lines to finish out the box. Then I'm just going to go, all my tails are touching. The tail of this one's touching, the tail of that one, the tail of that one. So only tails are in this corner, okay? And then I draw the head of my arrow at the opposite side of that box, okay? So this is now the direction of my resultant vector. That is why it was important to do, because I could have just used this equation and I could have found the magnitude of the resultant vector, but I didn't know what direction it was pointing until I went through this whole process, okay? So that's the direction of my resultant vector. Now, step four is to use Pythagorean's theorem in order to solve for the magnitude of this resultant vector. So let's say that this is 4 inches north, okay? And this is 3 inches west, all right? I need to figure out what my hypotenuse resultant vector with the longest side is. Doesn't matter how you call it. But just to show you all again why it is that we can use Pythagorean's theorem, you can turn this into a triangle. So this is the right angle, okay? Because these sides are perpendicular to each other. So that's my right angle, which means my triangle is all of this right here. That's my triangle, all right? So I know that because these sides are parallel to each other, these are the same length. So I end up with a triangle that is 3 inches on one side